So hey guys, welcome back to my channel. So in this video we are going to see another type of sorting algorithm, that is counting sort. Okay, so let's start. So counting sort is a non-comparison based sorting algorithm that works well when there is a limited range of input values. So in previous video we have seen many types of sorting algorithm. Okay, so like bubble sort, insertion sort, selection sort. So these are comparison based algorithm. So we compare two elements and we sort the array. Okay, so this counting sort is basically a non-comparison based algorithm, and the array should be in limited range. Okay, it is effective in limited range of array. Okay, now next point, the basic idea behind the counting sort is to count the frequency of each distinct element in the input array and use that information to place the elements in the correct order. Suppose in the array the element has occurred more than 2 times, 3 times. Okay, then we have to take its frequency and use that frequency to place the, basically to sort the array. We use that information. Okay, so let's see one example. I have created an array here and we have to sort this array. Then the to sort the array, this according to counting sort, the steps are, now the first step is to find out the maximum element from the array. So from the array we have to find the maximum element. Okay, so here we can see the maximum element is 6. So we have find the element, and next step is to make an array of the maximum element. So we have to make an auxiliary array of size of 6. Okay, so initially the array will be initialized with the zeros. Okay, next step will be, so we are here, we have to add the frequency count in the auxiliary array. Now we can see in our given array, so number of zeros occurred in the array is 0 only. So we have to take the count as 0. Then 1 is occurred here 2 times. So we have to take 2 here as the frequency count. Now 2 has occurred here 2 times. So here we also write 2. And 3 is not present in the array, so we will take a 0. Then 4 is occurred 1 times, and 5 is not present in the array, so we will take a 0. Then 1. Okay, so 6 has occurred 1 time. Many times the element occurred in the array, so we have taken the count of it. Now we will use this information to sort the array. For reference, I will write the given array here. So for reference, I have created the given array and the frequency count of it. Then the fourth step is to, according to the frequency of the count, add the elements to the array. Add the elements in the array according to the frequency count. Frequency count of 0 is 0 only, so we will not add anything. So frequency count of 1 is 2 times, so we will take 1 and 1, so this will be 0. Then 2 has a 2's frequency is 2 only, so we will take 2 times 2, and here we will reduce the count as 0. 3 is occurred 0 times, so we will not add the elements. So 4 is occurred 1 time, so 4 will be here. Then 5 has occurred 0 times, so we will not take it. 6 has occurred 1 time, so we will write here 6. So we have get the sorted array here. We have sorted our array, so we have taken the frequency count of the elements. Now according to that information of frequency count, we have add the elements to the array, and this way we have sorted our data. So let's see the pseudocode for counting sort. Now we will take a variable largest. We will initialize with the minus infinity, and we will run a loop for int I is equal to 0 to n, and the variable will be updated. Then largest will be maximum of largest variable or the area of I. So whichever will be the maximum, so it will add it into the largest, and our largest variable value gets updated. Now we will create an auxiliary array. So here in, now we have to create our new auxiliary array of the largest number present in the element. So we will take the range as largest plus 1. So why have we have taken this plus 1? Because of array starts with 0, so that's why we have taken the plus 1. Okay. Now here also we will run a loop for int I is equal to 0 to n, and in that we will count our elements. So count array of I, and it will get updated. Now for sorting our elements, so we will take a variable j is equal to 0, and we will run loop for int I is equal to 0 to n, and in that we will run a while loop while count of I should greater than 0. So till the while loop will be run, and array of j is equal to I, j will be gets updated, and after adding the element to the array, so we have to decrease our uh, auxiliary arrays frequency count. So that's why we have done the decrement, and we have to close the brackets. Now this is the pseudocode for counting sort. So first we have initialize our largest variable to minus infinity, then we have run a loop, and we have done a comparison. So variable and the array of I, whichever is the greater, so it will add it into the largest variable. Now here we have created an auxiliary array size largest element plus 1, and we have run a loop, and we added the frequency count of the elements. And here in this process we have done the sorting part. So j, and we will initialize as 0, and we have run a loop from I is equal to 0 to n, and we have run an inner loop while count of I, means count in the auxiliary array, should be greater than 0. Then our array of j will be gets updated by I, and j will be gets updated here, and whatever the value present in the auxiliary array, it will gets decreased. Now this way we have created pseudocode. Now let's see in our practical session. I have created a class called demo. In that I have created a main function, and now we will create an array here. So I have created an array here. Now we will write a function. So public static return type will be void, and name will be counting sort, and we will pass our array in the parameters. Now here we will create an variable largest, and we will initialize it by the minus infinity. So we have initialized the largest variable to the minus infinity. Then we will run a loop here for tint I is equal to 0, and I should less than array of dot length, and I will get updated. Now here we will update our largest variable. So it will be math dot max largest and array of I. So it will compare, and whichever is the maximum, it will added in the variable. Okay. Then we will create an auxiliary array here. Okay. So in count new int here we will write, and the size will be our largest element plus 1. So because of the array starts with 0, then we will run a for loop here for int I is equal to 0, and I should less than count dot length, and I will get updated. Now our we will add the frequency in of the element in the auxiliary array. So count of array of I, so it will get updated. by 1. So we have added the frequency count of the elements in the count array. Now just we have to here sort the elements. So for sorting, we will create a variable j is equal to 0. We will run a loop for int I is equal to 0. I should less than dot length, and I will get updated. Now here we will run a while loop while count of I should greater than 0 and array of j will be I, and j will be gets updated, and our count of I will be gets decreased. Now to print the array, we will create another function. So public static void and print AR, and we will pass our array here for in I is equal to 0. I should less than array of length, and I will get updated. Simply print our elements I, space, I. So this is for next line. Created our function. So first function we have created for sorting the elements through count sort, and then we have created a second function for printing the elements. Now let's call the functions from the main method. So here counting sort be okay, and here we have to print our sorted array. I've done a small mistake here. We have to run a loop for the our array, not for the auxiliary array. So we have updated here. Now let's run the code and see what will be its output. So the output that we have get as a sorted format, and we have passed this original. So this way we can create our counting sort algorithm. So thank you for watching this video.